Conditional access policies are a great way for organizations to create custom controls to define how users are authenticating to Microsoft 365 and Azure. They're used to define things like when and where MFA gets applied during that authentication process. Now, occasionally, policies get created that enable single-factor access. Why would you want to do that? Occasionally, you have exclusions you need to make, and occasionally mistakes happen, and those rules get overly permissive and defined to encompass more than what was initially intended. So in this video, I'm going to show you how external attackers can find those MFA inconsistencies and then exploit them to authenticate single factor. So what are conditional access policies? According to Microsoft's documentation, at their simplest, they are just if-then statements. So if a user wants to access a resource, then they must complete an action. So for example, I have an application that I want to ensure that MFA is enforced every time somebody authenticates to it. I can create a conditional access policy that makes sure that any user that authenticates that application, they have to go through MFA. Conditional access policies can get a little bit more complicated than that, though. So users are only one of the signals that can be utilized to describe what requirements are necessary for a user to be able to authenticate and when and if MFA is even applied at all. So there's a number of things such as the location. So that could be things like IP address, the device that they're using, the application they're using to authenticate with, and what is called a real-time risk. So let's look at each one of those a little bit more in depth here. When it comes to assignments, first, we've already said users, right? So you could assign it to specific users. You can also assign it to Azure Active Directory groups. You can assign policies to cloud apps or actions. And then the conditions is where we start to see these policies get defined out in more fine-grained detail on what exactly is allowed to authenticate, single factor, multi-factor, or just be blocked altogether. For example, sign-in risk is our first one here. So this is for organizations that have Azure AD identity protection. The risk detections generated there can influence your conditional access policies. Device platforms. So this is a really interesting one. So organizations with multiple device operating system platforms may wish to enforce specific policies on different platforms. This is one we're going to look at in a little bit as well. Locations. So location data is provided by IP geolocation. So you can actually start to block certain areas of the world depending on their IP address. Client apps. So this would be the software that the user is employing to access the cloud app. So for example, browser or mobile apps and desktop apps. And then device state. So this control is used to exclude devices that are hybrid Azure AD joined or marked as compliant and in tune. And then there's a filter for devices as well that allows you to target specific devices based on their attributes in a policy. And then finally, we have the actual access controls. It's literally a grant or block access depending on the policy you're creating. And when you grant access, you can actually trigger enforcement of one or more different controls. So you could require multi-factor. You could require the device to be marked as compliant. We could require hybrid Azure AD joined device. The number of different settings that you can enforce as well. And then there's session controls you can create as well, where you can limit the experience of the user after they have authenticated. So let's take a look at what a simple conditional access policy might look like. So in the Azure portal here, if I navigate to policies, I can see that I've got a geolocation blocking policy here. So I created a very basic policy that simply just blocks everything that's not a United States IP address. And we all know that, you can VPN places, so this isn't a great control. However, it can show, what you can do with conditional access policies. So for example, here we've got the users that we want to assign it to, right? And I assigned it to all users. You could assign that to a group as well, or a specific user. We've got the cloud apps. So what applications are we actually applying this to? We're going to apply it to all the cloud apps in this case. And then conditions. This is where we start to define out those policies around device platforms, location, client apps. So this is where if you wanted to, enable legacy auth, this might be where you do that, or block legacy auth, hopefully. And then in this case, I created it under locations, right? So I created any location we're going to block access to, right? So the grant is actually block access with the exclusion of United States. To do that, I need to select United States from my geolocation list, which I created under named locations. And then we save that. And now that's a simple conditional access policy. So that policy, should take effect, and my authentication from anywhere in the world should get blocked if it's not coming from a United States IP. So I've seen similar policies like this that organizations are leveraging to do things like block geolocations, where simply just VPNing to the right place gets you around that rule. In other cases, I've seen where organizations lock things down to just their own IP space, where unless you are originating your authentication request from within their own network, then it gets blocked. So you can start to get really detailed with how you define where users are authenticating. Another common requirement that we see used in conditional access policies is what's known as device platforms. And device platform is basically a way for organizations to say, hey, I want to apply this rule to just iPhones, or I want to just apply this to Windows devices, or Linux, or Mac OS. And the problem with this particular policy configuration is that is 100% based off of user agent. Is how they're determining whether or not you match up with that policy or not. So let's show an example real quick of how this might look in the real world. And this is something that we see in the real world pretty often. So I've got a Windows VM here. I'm gonna authenticate with the browser here using a credential. Let's say we password sprayed this credential for the intern at glitchcloud.com, right? We were able to somehow compromise this user's cred, whether it be password spraying or cred harvesting in some case. Maybe we phish them. But either way, we have their credential and we go to log in. And what happens? Oh, we've got MFA, right? So we don't have their phone, so we can't actually complete the MFA process. How do we find single factor access? Well, I ended up putting together a tool for this specific scenario that I call MFA sweep. And the idea with MFA sweep is that it attempts to authenticate to a number of different Microsoft services. So Microsoft Azure has a number of different endpoints to authenticate to. First off, there's a couple different APIs. There's legacy auth portals like Exchange Web Services and ActiveSync. Occasionally, organizations are leveraging ADFS for authentication. And then we've got the web portal and those various device options. So remember, I mentioned how the user agent string is how that's driven. So the tool basically just tries to authenticate to each one of these and determines whether or not MFA is a requirement for authentication or not. So let's run MFA sweep and see what kind of results we get with that set of credentials that we just saw has MFA on it. All right, first up, I'm going to open PowerShell. Then I'm going to cd to the desktop. I'm going to import module MFA sweep.ps1. And then I'll import the script. And then it's as simple as just running invoke-MFA sweep, give it a username. So in this case, it's the intern at glitchcloud.com, and the password that I maybe password sprayed was spreadsheets for life. They're in Excel all day, right? So this script can also attempt to determine if ADFS is configured. I know for a fact it's not on this domain, so I'm not even going to bother with that, but you can do that if you want. And then it will prompt you to alert you and say, hey, you're about to log in 10 different times to this account. Are you sure you want to do that? Because again, remember, if you had any sort of lockout policy for this account, that might lock it out if you have the wrong password. But if you got the right password, it should authenticate successfully to each one. Now, what you'll see is a various set of messages that start to come back as it goes through each service. For the first one here, we've got Microsoft Graph API. We can see there was success that it was able to authenticate to the Graph API, but note the response indicates that MFA is in use. Okay. So what about the rest of these? So same thing, success, MFA is in use. And then you'll start to see the web portal checks, right? So with a Windows user agent, it says it appears MFA is set up for this account. With a Linux user agent, it appears MFA is set up for this account. With a Mac OS user agent, it appears MFA is set up for this account. So we start to see that MFA is applied, looks like everywhere, right? So let this finish up and see, oh, what is this? What's this we got here? Microsoft 365 web portal with mobile user agent iPhone. So iPhone, it appears there's no MFA for this account. And then at the very end, it will complete the legacy auth checks. Those also failed, but we got a single factor access results summary here where we can see all of the portals that we were not able to authenticate single factor to. However, there was one, yes, right? And so we can see here, O365 with iPhone user agent was a yes. Okay, so let's go try it. Okay, got a fresh browser here. I went ahead and deleted all the cookies as well. Edge has a built-in emulation mode where you can navigate and change the user agent string simply by going to the mode here and clicking the drop-down. I'm going to use Apple Safari iPad to emulate our iOS device authenticating, since we saw that iPhone user agent was successful. So let's go ahead and try it now. So the same account, right? The intern at glitchcloud.com, and then spreadsheets for life is the password. And let's see what happens. So when we authenticate this time using an iPhone or iOS user agent string, what do we get? We are authenticated. It doesn't ask for MFA. So simply by changing our user agent string to be an iPhone user agent string in this case, bypass that MFA control that was previously right up front on the main Microsoft login portal because we were using, the standard Edge user agent string initially. So let's say you have the ability to authenticate to an Azure Active Directory account and you want to start looking for other conditional access loopholes that might be there. Well, one of my favorite ways to go about doing this is by using a tool called Road Tools by Dirk Jan Malema. So Road Recon is a part of Road Tools, and Road Recon will authenticate to your Azure account and then pull down a bunch of information like users, groups, service principals, applications, and probably my favorite piece is the ability for it to grab conditional access policies. So let's go ahead and use Road Recon to go analyze conditional access policies. Now, when you authenticate with Road Recon, it will store your authentication data in a session file on disk. So after you've authenticated, you can run Road Recon gather, and it will use that session file that's local on disk to authenticate to your account, and then start to collect all the objects, like I mentioned, like users, groups, that kind of thing. And then when that's done, we can start to look at the plugins that are available as well. So Road Recon has plugins. If you run Road Recon plugin-h, you can see the other plugins that are available. So there's policies, which is the one we're going to use to parse conditional access policies. There's a Bloodhound plugin. There's an XLS export and a Road to Timeline plugin now as well to generate a forensic timeline from Azure Active Directory object timestamps. So let's run Road Recon plugin policies. And what that'll do is it should create a caps.html file in the directory that you ran it. So if we open up that caps.html file, let's take a look at it. So we can see that we have two conditional access policies, and this is exactly what we had in the portal a little bit ago. So we've got a geolocation blocking. We can see it's in report only currently, but you can see what it applies to. So it applies to all users except the Space Monkey user, and it includes all applications. All locations deny logon except for United States. And so you can start to, look through each one of these and try to identify other loopholes that might end up being findings later on. I hope this video helped demonstrate how mistakes can sometimes be made when it comes to the creation of conditional access policies. If you're a pen tester, you may find that you compromise some credentials, go to log into that main Microsoft login portal, and you're hit with MFA. So it's worth looking around to see if maybe a conditional access policy was made overly permissive and see if you can find single factor access anywhere else, or using any other methods for authenticating to Azure and Microsoft 365. So it's definitely worth testing from the outside and for organizations to audit all of their conditional access policies on a regular basis. Thanks so much for watching. Make sure to subscribe, and I'll catch you in the next episode.